Okay, students, so we are on page 115 of the notes, and we're going to be working with the data given in example 10.3. Now, if we recall from using our two variable statistics from the previous page, we have the sum of the x's, sum of x squareds, and so on. Now we're going to calculate the standard error of estimate. This is often labeled SE, but in other books or computers or sometimes calculators, it's denoted with a capital S, so be aware. I'm going to do this by hand. However, all of this information, with exception perhaps of the standard error of estimate depending on the model of calculator, usually can be done with your calculator. So you already know how to get A and B from your calculator because we usually discuss that in class. But I'm going to do it by hand the old-fashioned method. So y bar is the average of the y's, which is 24.56, minus b, which is 7.67603, and you're like, how did you get that? How did I get that? I needed to do b first, times x bar. I cheated. Let's do b first. If you have to do it by hand, you need to calculate your b first. So this would be 5 times the sum of the xy's, which is 619.6, minus the sum of the x's, which is 21.4, times the sum of the y's, which is 122.8. All of that is divided, and watch that decimal, is divided by n, which again is 5, times the sum of the x squareds, which is 103.84. Excuse my handwriting. Times the sum of the x's, which is 21.4, and you want to square that. Once you do all of this information carefully, again parentheses around the very top, very bottom to keep everything separate, you should be getting 7.67603. So that's your b. Again, you plug that in here for your a. You calculate y bar by taking the sum of the y's dividing by n, and you calculate x bar by taking the sum of the x's dividing by n. Remember your formula for averages. On A, you should be getting negative 8.29341. How many ever decimals you took it out to. So that's A and B. Now you need A and B in order to do the standard error of estimate. So big square root. The first calls for the sum of the y's squared. So each y value squared, and then you summed it together. So that's 3901.46. Big division line. Minus A, which is the negative 8.29341 times the sum of the y's, which is 122.8, minus b, which is 7.67603 times the sum of the xy's. Now the sum of the xy's is, let's see, sum of xy's, where are you? Oh, there you are, 619.6. And I ran out of room on that piece of paper, didn't I? All over n, which is 5 minus 2. If we work this out, we should be getting 7.38769, which is what we wanted to get. A little bit of rounding error involved with mathematics, but it is quite close. And the equation of the line, of course, is negative 8.2934 plus 7.67603 times x. So again, down here when we want to make a prediction using the equation of the line, we write our equation of the line. We open up a parenthesis and we insert the x they're giving us, 4.0, plus the bx, but the b is negative 8. I wrote mine backwards, plus the a, sorry, which would be 29341. And when you work that out, you should be getting 22.4107. Roundabouts, partial pressure, mmHg over 10 millimeters, I assume. I don't know what Hg is. Over 10, some kind of medical unit, which is great. But that should be our answer for yPredict, and you've done yPredict before. We did it on a few pages back. So that's how you calculate the SE. And again, my calculator can do this for me. It has, when I bring up linreg, it will do SE for me, and it denotes it as a capital S for SE. Other calculators, depending on the model and how advanced they are, they usually don't have that in their linreg functions, especially the little tiny little blue $14 calculators. They do not have SE to my knowledge. But that's how you work it. So there you go. And that's doing it by hand. Remember, a lot of that stuff can be done just bringing up the linreg in your calculator.